Hey everyone, I'm going to let everyone get logged in here, so hold tight real quick and then we'll get started.
See if I recognize anybody.
Oops.
Yeah.
Some familiar names.
Yeah.
Welcome everyone.
I love it. So fun. I can't wait till next conference. Yeah.
For sure.
Rockcliffe. Gosh, man. You see, you like everywhere I'm at, Rockcliffe. Remote
We're
Rockcliffe.
going to run out of room for participants soon.
Wouldn't that be great? What a great problem that would be.
All right, everyone. Welcome. My name is Monica Lee. I'm the marketing director for Viscosity North America. We are a full Oracle stack consulting firm, and we love partnering with NYOUG. That's the New York Oracle User Group for webinars like this. I'm going to tell you a little bit about Viscosity. I'll go over a couple things to note about today's session, and then I'm going to hand it over to NYOUG and our speaker. So really quick about Viscosity. If you're not familiar with us already, we have core expertise in Oracle database, including RAC, Oracle Apex, zero downtime migrations, performance tuning, high availability. We've got decades of experience with infrastructure, including engineered systems. We were the Oracle Partner of the Year for the ODA. So if that interests you, hit us up. We've been upgrading many of our customers to Oracle Database 19c, and we've been hosting monthly workshops through our newly acquired orapub.com, which I will also talk about a little bit later too. So right here, you'll see Viscosity is built on 3 pillars: data, apps, and infrastructure. And across the bottom, these are things we offer for all 3 pillars, from health checks to training to managed services. Our team carries us. They are amazing. These are a couple spotlights for our Oracle Aces throughout Viscosity's team. So hopefully you recognize some of them, including today's speaker, Craig. So if you've not heard from any of these guys, they're awesome. They present coast to coast at things from Oracle Open World to regional user groups like NYOUG, and even abroad. These are some of our broad services we offer. So if you're interested in anything here, especially things like license management, if you need custom apps, if you need migrations, those are things we offer and are very popular for Viscosity. And some of our expertise, hopefully they're sitting on your bookshelves or in your Kindle. These are all books that we have throughout our entire team, from infrastructure to cloud. And I wanted to bring up Orapub. Craig is the founder of Orapub. We brought him on at the end of last year and took on Orapub to house all of Viscosity's webinars like today's, lots of workshops we do, and things Craig consistently does that he's been offering Orapub members since when, Craig? I don't even know when you started.
Well, as soon as I left Oracle, 98.
98. Okay. Well, that basically tells you there's a lot of information out there. There's a lot of information. You can register here as a free member. There are paid tiers as well, but even as a free member, you have so many resources. I highly recommend you go there. All of our webinars that we do like this that are free to you, they are there for you to watch. There's also slide decks for you to look at, and you can also catch some of our paid workshops, which are, they're very full, they're very in-depth. Many are multi-day, and many are things your company will probably reimburse you for. So definitely think about that and check out orapub.com. So with that, I just want to let you know, this is some stuff we've got coming up. Next week, we're actually in person in Chicago and in Salt Lake City. So if you're in those areas, go to our new events page, events.viscosityna.com. You can see what's coming up and register for things from there. Next Wednesday, we're actually just doing a happy hour meetup in Chicago, and that's with the Midwest Oracle User Group, Chicago Oracle User Group, and OD-TUG. Salt Lake City is a lunch and learn on cloud and performance. Craig is going to be speaking there, as well as our CEO, Charles Kim. And if you have any information, I know I probably went through that very quickly, email my colleague, Katie Barnes, katie.barnes@viscosityna. And before I turn it over to Coleman, I just want you to know today is a live webinar. You've got Craig's attention. Please use that Q&A field. He'll get to your questions as he can. And if not during, he'll definitely acknowledge your questions at the end. And anything we don't have time for, you can always ping us, email Katie. You'll get a follow-up anyways. So please use your resources today. You've got Craig, which is an amazing technologist. And I'm so excited to have you here with us, Craig. And I think that's it. I'll go ahead and give it to you, Coleman.
All right. Thanks very much. Let's get to the right screen on here. So welcome everybody to this joint webinar between Viscosity and NYOUG. We were just talking a little while ago. This has been going on for almost 2 years, and we're looking for the continued relationship with Viscosity and with the New York Oracle Users Group. We're always open for abstracts. It's on your screen. Call for abstracts by screen sharing? Yeah. Call for abstracts, New York Oracle Users Group, call abstracts. Next page. You can connect with us on Twitter, Meetup, and of course the abstracts, LinkedIn, Facebook, and our website. And once again, thank you Viscosity North America for co-hosting a series of webinars. And I want to thank Craig for giving a presentation today. And by the way, Craig is a longtime Oracle DBA specializing in predictive analytics, machine learning, and Oracle performance tuning. Craig is a researcher, blogger, consultant, author, running out of breath here, an enthusiastic conference speaker, passionate teacher, and is also an Oracle ACE director. And again, thank you again for co-hosting these series of webinars with us today. Craig, thank you again.
All right. Hey, thank you guys for having me. It's really good to actually kind of see people. Yeah. Can you guys see my screen okay? Anybody?
Yes. Yeah, we
okay.
can see it. Absolutely.
All right. I guess that means the audio is working also. So fantastic. All right. So we have about 15 minutes. Well, hey, welcome. It's really great to be here to actually present to you guys about this. Just so you know, I didn't sleep hardly at all last night. We had a storm and it hit our house. So either I was awake or Katrina was awake while I was asleep, which means that I actually woke up. So if I get a little weird today, that's probably not my normal self. So with that said, I do get to talk about something that I really enjoy, and that's AWR report analysis. So, but this is a little different than like my typical AWR report analysis. I am going to do like a demonstration at the end to actually do what I'm going to talk about. But really the goal is just what it says here. This is going to be how to do something, and it's how to actually quickly set up your analysis. What I found is that if you get it set up at the beginning, now I don't want to do the full, well, actually I can do the full screen right now. Yeah, I will do that. But then in the demo, then I will not do that. Is that better? Hopefully that's better. Of course, now I got stuff all over my screen now. Hold on a second. Yeah, what was I going on? Oh yeah. What I found is that, no problem, Paulie. If you get it set up right, which is really the focus of today, then you're probably going to do fine. All right, it's because if you don't get it set up right, then the likelihood of success like dramatically decreases. That's what I found. So anyway, so that's why we're going to be doing what we're doing today. All right, let's go to the next slide here. So what I've, some of my motivation is that when I work with people about this, typically, when somebody's confronted with an AWR report, even if they go to some kind of training, but they're actually like at their system for the first time when they come back or something like that, you either like freeze, I see that a lot, or those people will start just kind of flipping through the pages looking for something that stands out, that's interesting. A lot of people, and they'll end up just like guessing, like none of these are a really good career advancing, move. And so really one of the things that I hope you leave with here is that when you look at an AWR report, it almost becomes mechanical in terms of the setup. So you can just relax, basically find the numbers you need to find, right? And then enter them into like this kind of a simple framework. And then from there, that is when like your analysis expertise and everything really starts to shine. That's what I'm hoping is actually going to happen. So here's how we're going to do this step by step. Okay, now my camera is, hold on, my camera is in front of since we're going full screen here. Let me see. I don't have everything memorized here. All right, so this is what we're going to do step by step. First of all, you need to know really what this is about is when not to use an AWR report, since that tends to be the first thing most DBAs go to. If it's not like the right tool for the right job, you're going to crash and burn big time. And I want to make sure we actually cover that. Then in order to use an AWR report analysis, or in order to use the AWR report, the way that I'm going to teach you, we need to have an understanding of Oracle's time model. We don't have to know all the details, but we need to understand that fundamentally. So I just have a couple slides about that. And then I'm going to show you how to actually set up what this framework I call an Oracle time-based analysis. I'm going to show you how to do it. And then I'm actually going to do one for you. So you can kind of watch me go through the process. It's actually like a real production database. It's pretty old now, but it's actually real production. So, the other thing, what I'm going to teach you, it like works with any version of Oracle. As long as the time model is active, which is what, Oracle 7 or something like that. It's still going to work, and regardless of the architecture too, it's not going to make any difference. So, wow, my screen just, there we go. Man, my screen just went into screen share mode. All right, let's go to the next slide here. What the heck? Here we go. All right. Yeah, so I'm Orapup's founder, Viscosity's applied AI scientist, and I think you guys heard from both of Coleman and Monica enough about me. So I'm just going to go to the next slide here. All right. And you heard about all the stuff Viscosity does too. So I don't need to talk about that as well. So I'm super impressed with all this the people I meet at Viscosity. I knew of them, before I started working for them, and it's been really good. Yeah. What's on the outside is pretty much what's on the inside. That was really nice. So I'll say that. All right. So we're going to start with the first point right here is know when to use and not to use an AWR report. All right. Super important. Okay. So just by looking at like this right here, these top foreground weight events, you can see that, hey, this is not about session level stuff we're looking at here. And a lot of people get super frustrated with that, but because you can't drill down to the session level. But that's okay if you understand that by design, it's actually like built this way, right? The AWR reports were actually designed, right, to focus on like an entire instance or an entire cluster, that kind of thing. And it's not a mistake. It's actually like built that way. So what this means though, is that if you need to go down to a lower level, like at a session level, then an AWR report is not going to get you there. And that's important because if you go through the process of setting up the analysis, coming up with solutions, you will still come up with solutions. But those solutions will be focused on the overall instance or the overall cluster, that kind of thing. So you'll get answers and they'll be legitimate, but it might be the wrong problem that you're actually supposed to be solving. So you got to watch out for that. So let me give you an example of this. So let's say, you do your AWR report analysis, the way that I'm going to be talking about today. And you really, you figure out that, hey, the AWR report is really saying at the heart of this thing, it's a physical IO read issue. But if you talk to the users that are really complaining, they're saying, hey, man, like our screen just like randomly locked for a minute. And so you listen to them and you look at the AWR report and you're like, how in the heck, it doesn't reconcile. It just doesn't, you just can't do it. Well, that's because you're dealing with the few users, right? And what I like to say is that an AWR report lets us look at the ocean of activity, or like the current of a river, right? And there's all these fish that are like swimming with the current. Well, these few users are kind of like swimming upstream, going against the current, and they're there and they're important, but it's all the other fish and just the big current. That's what an AWR report is going to pick up, not the little fish. So if you're tasked with working with a few users who are having their screen locked and everybody else is like, what's the problem? Then an AWR report is not going to be your best bet. In fact, don't even, well, it's nice to look at. You get an overarching view of what's going on, but that's probably not going to solve your problem though. You should use ASH. Okay. So just remember, by design, that's not what it's about. So if your AWR report says, hey, the heart of the issue is CPU and IO, that's where it's at here. And then the users say, hey, performance is slow like every Friday afternoon. Well, then, okay, we're talking like users, like the system, right? It's like system wide. This is not a surprise. When I used to go on site a lot, I remember they say, hey, okay, make sure you're here like at this time when you show up, because that's when the bad stuff's going to happen. See, they were expecting system-wide problems. That's perfect for an AWR report because it captures like the flow of the river of what's happening. Okay. So it's kind of fun to listen to people say the things. They're like, yeah, exactly. It's system-wide, it's expected, and it's going to be bad. Yeah. And you're like, yeah, it's good stuff. All right. So that's when to use and not to use an AWR report. So let's assume that it is appropriate to use an AWR report. Well, the next step is we need to understand Oracle's time model. Okay. So this is, and you really need to believe this. Okay. Otherwise, you're not going to have confidence in your analysis. So the fundamental, belief is that users experience performance through time. Right? If you listen to people, and we're like this too, right? It takes too long. It takes too much time. And we even speak this. It's just so crazy. So it's like, they experience performance through time. So if our analysis is time-based and their experience is time-based, there's got to be a way to create some kind of link between the two. So what I mean by this is that if our analysis, if we can reduce the time in the analysis, then the user experience should improve. Now that's a general statement, but I'll just say it's a really good general statement. So what we're trying to do is to create a link between our analysis and the user experience and its numbers. So we have a quantitative link, which is like really powerful. Now, is it perfect? No, it's not perfect, but we're not trying to land a man on the moon kind of a thing, right? It's Oracle performance analysis. So, but that's important that you understand that user experience is based on time. Our analysis is based on time. What I'm going to show you how to do is to create this quantitative link. So if we reduce time, the user experience improves. Okay, that's what we're going for here. All right. Okay, I can't see the bottom of my chat here, just in case. All right, excellent. Okay, all right. So Oracle time. All right, it's actually really, thankfully, it's really straightforward. Okay, of course, the devil's in the details, right? But an Oracle process, if you can see it in $V session, it's either burning CPU or it's not. I know that's really profound, right? Burning CPU or not, all right? And if it's not, it's either waiting, right, on an idle wait event or a non-idle wait event. So, it's either waiting or not waiting on CPU or not on CPU. And I'm really not looking forward if they ever change that, because that's gonna, it's gonna be way more complicated, I'm sure. So if we're looking at a single session, and let's just go like left to right here. So the C is, hey, we're gonna burn let's say burn 5 units of time of CPU. Okay. And then for some reason, we're unable to, or the process is unable to burn CPU. Because the way I look at it is a process, Oracle processes, they want to burn CPU, right? They live for CPU, because when they have CPU resources, they can run Oracle kernel code, which is awesome, right? That's like life to them. So there's got to be a really good reason why a process is unable to burn CPU. And the gold here is the wait time. This 4 units of time gives us clues about why the process is unable to burn CPU. Think of it like that. In fact, we're not going to get into this now, but you can actually verbalize this and even write this. Like the process is unable to burn CPU because, and the wait event gives us the clues about the, what we're going to fill in. All right, so we're burning 5 units of time of CPU. We're waiting for 4 units of time. Burn 3 units of CPU time, and we go on. So this could be looking at all sessions. This could be one session. You can break this down all sorts of different ways. But however we're breaking it down here, we're saying that the CPU consumption was 14 units of time and the non-idle wait time was 6. Okay, this is important now. You add the 14 and the 6, of course, you get 20, all right? That's the elapsed time and the database time. Now, sometimes elapsed time does not equal the database time. Okay. And I'll just say generally, the reason is because the data for elapsed time and database time, actually it comes from different sources. So the numbers don't always add up, which can be super frustrating, but there's ways to figure that out too. But that's way out of scope for what we're going to be talking about today. All right. So we have our CPU and our non-idle wait time. Okay. And that's the elapsed time and the database time. Okay. All right. So that's just a real quick introduction to Oracle time model. And I kind of hinted at, so, that doesn't always add up, right? So that can actually happen. All right. So how do we actually set the analysis up here? All right. First of all, you're going to notice when I start coming up with solutions, I'm going to come up with application focused solutions. Like let's look at we need to find a particular type of SQL statement. There's going to be Oracle focused solutions, like let's change these, instance parameters or something like that. And then there's going to be operating system solutions, like we need more power somehow, or let's get rid of processes that are consuming the resource that's in short supply. So I use this like all the time, because every one of us tends to value one of these circles more than the other. Yeah, it's funny when you talk to people say, oh, it's always the SQL, Craig. Like you're a fool if you even talk about the OS or something. Or like, we're not going to touch Oracle. Nobody changes Oracle parameters. I'm like, well, yeah, actually they do, Or you talk to like a real hardcore performance Oracle person. They're like, application SQL, I did that years ago, whatever, The OS, whatever, everybody, and the OS guys are even, they're just as bad as we are. So what this forces me to do is to come up with solutions, at least attempt, and there's almost always at least 3 solutions. But they all are centered on one overall goal. And what is the goal? That's what I'm going to show you how to figure that out next. Okay. So just be aware, and I'll try and highlight this also, this whole 3-circle thing. It's just like, it's so ridiculously simple and it works so good. So this OTBA, what is that? All right. That stands for like Oracle time-based analysis. I just get really tired of writing that out. So I just put OTBA. Okay, so what we're going to do is we're going to look at, like those top events, and we're going to classify those. We're going to put them in buckets, and then we're going to add up the time in each of the buckets. And what's going to happen is some buckets are going to have a lot more time than others. Surprise, right? And those represent opportunity for us. Because remember, a lot of time means a lot of pain for the users. So we're looking for the pain, believing there's this quantitative link going on that I talked about before. Now, how are we going to divide or classify the time? Well, I am really a big believer in simplicity here. So what we're going to do is and it's based on Oracle's time model. So with our total time here is going to be, we got 2 big chunks, all right, CPU time and then wait time. And this is going to be non-idle wait time. Okay. I don't use idle wait time when I do this unless I'm working at the session level where I can tell that the non-idle wait time is actually impacting a user. And to do that, I really need Ash to do that, which I love Ash. Ash rocks. Yeah. But that's not what we're going to talk about today. All right. So within CPU, we're going to be consuming CPU. We're going to be waiting to consume CPU. And I'm not going to talk about, CPU queuing at the OS. That's way out of scope for today. All right. But that's one of the reasons why the numbers might not add up right. But I'm not going to say anything else. So, but we are going to get the foreground process CPU consumption and the background process CPU consumption as well. And that's going to be part of our framework. And then on the wait time side of the thing, I break it up. It's either IO or it's like everything else. And if it's IO, then we're going to have some read focused wait events and some write focused wait events. Okay. Sometimes they cross over a little bit, but listen, don't panic if it doesn't fit perfectly, right? Again, it's not a man on the moon kind of thing, right? Okay. What about all the other classifications that Oracle's come up with, like 12 or 13 of them, right? Well, that's complicated, right? And so what I found by doing this, literally, it's got to be thousands of times, is that if it's not IO and it's something else, the main others wait events tend to tell the same story. So they just kind of bubble up to the top and oh yeah, that makes sense. They're more network related, or they're more caching or latching related, something like that. Right. So you don't need all these different categories. I love this setup because people get it, right? Which if people get if I can explain the performance situation in a way that a 12-year-old gets it, surely management will understand it. And if they understand it, they were much more likely to embrace my solutions. And that's what I'm going for. I don't want to get in a stinking argument about an Oracle solution. I mean, come on, So people get it's either CPU that's being consumed, that's a problem, or it's not CPU. And if it's not CPU, people kind of get it's either IO or it's something else. And if it's IO, people think, yeah, a spinning disk, we're either reading or writing. Correct, Craig? Right? Oh, yeah, you guys got it, man. Yeah, yeah. And so that's what I'm going for. And if it's not IO, well, then it's something else, maybe locking. Oh, yeah, okay. So people get this. I love it this way. And they're much more likely to embrace my solutions then. So let me give you an example of this real quick. So this is an example where I got my top events right there. And I'm going to take that information and we're going to put it in our classification scheme here, right? So you can see we're going to get the data. The data is, in this case, it's an AWR report, but you can get it wherever you need to get it. You write your own scripts, doesn't make any difference, but you got to get the time-based data. Okay, then we're going to classify it. And this is the way that I do it. I'm going to show you. And then I look for the big piles of time. And then every single one of my solutions will point to one of these big piles of time. Okay, now this is actually really important to me because I use the big piles of time as my guide. When I come up with a solution, remember the three circles, when I come up with my solutions, I need to be able to say, Craig, how is that solution going to change and alter this time classification in a way that's going to benefit the user's experience? All right. Now, usually it's reducing time. Now, it can also be increasing throughput, but that's a little more advanced, and we're not going for that today. Okay. And so I need to understand how the solution will alter this time classification here in my favor, which is going to benefit the users. If I don't understand how it's going to do that, then there's no way I'm going to recommend that solution. Okay. Now, this is really powerful because you can flip this. Somebody comes to you and they say, hey, somebody comes to me and they say, hey, Craig, we need to do this. And I'm like, well, how's that going to change this, the situation? They're like, well, and they go around. I'm like, well, then we probably shouldn't implement that, right? Even better is when a vendor says, hey, this is what we need to do. We need more CPU. You need to purchase some more CPU license, blah, blah, blah. You're like, so how's that going to help the user experience here? Like, where's that, save your company thousands, millions. All right. Okay. So that's how we actually set it up. Now, how do we actually do it though? Okay. Well, it's very similar, right? This is pretty much the same slide, but on a piece of paper or a spreadsheet, which I'm going to use today. It's the same classification: CPU, non-idle wait time. CPU is foreground and background. For the non-idle wait time, I got my IO and my other. And for IO, we have reader writes. And I just grab, these, it's like an 80, 90, 10 kind of thing. I grab most of the wait time, and I'm going to classify the wait events. And the CPU time, you just grab right off the report. And then with that, I'm going to come up with some solutions based on my three-circle analysis. Pretty straightforward, right? I love it. It works. All right. So this is kind of what this is based on that previous slide right here. Okay. So let's say our core objective is to actually, reduce time here. It's not going to be increasing throughput, this time. So you ask yourself, well, what are the big piles of time? Well, if you look at this, we can see what CPU, non-idle wait time, they're pretty, in my mind, that's like basically the same. Okay. And so it's going to be latch, cache, buffer chains. That's what CBCs for cache buffer chains. So those are my two big opportunities. I got a bunch of CPU time, which is a huge, it's like basically half, right around half of the user experience time. And then we have this, this waiting to get this cache buffer chain latch. All right. So those are my two big opportunities. I'm not going to get distracted, from other things. Okay. Now with cache buffer chains, we need to find out some more stuff. All right. We don't have enough information yet, but we know that when we start, understanding how they're being used, why, and that kind of thing, that we're focused on the right path, because that's where that big chunk of time is. So it's like worth our time to go down that path. Okay. Now, let's see. There's going to be, we will find more about this, but in terms of SQL statements, think of the application circle. Okay. So let's just go back a slide. I'm going to be looking for SQL statements that are burning a whole heck of a lot of CPU. So when I talk about the top SQL, what I'm really talking about is the top CPU consuming SQL. That's what I'm going to be going for. Okay. And that's also highly likely the same SQL that's going to be waiting for these cache buffer chain latches. Okay. So I'm using what I see here to help me identify the SQL that I need to find. Okay. I mean, it's pretty straightforward. And then I need to find out, is there a CPU bottleneck? Because if there is, right, since this is, from an OS perspective, we're talking CPU right here, right? It's not IO, CPU. So I need to find out if there's a CPU bottleneck. And if there is, then I can ask, hey, a short-term solution would be, can I have some more CPU resources, at least in the short term? And of course, if you're in the cloud, they love you now, because now you're asking for more CPU. In fact, why even tune the stinking SQL? Because we'll just give you more CPU, right? That's another path we're not going down. All right. So that's just an example of that. All right. Of how you can actually do this. Now, of course, it's easy to talk about, right? But when you look at your real data, it's always more difficult, because it's like I don't know, there's something about that, right? It's just like, it really counts. It matters then. All right. So you need to practice this in a safe environment. That's what's good about classes. When I do my AWR classes, you can mess up all you want, and you're not going to shut anything down. All right. So, but to help out, I'm actually going to do one, and we have, we're doing good on time. And so you'll watch me do it, and, maybe you can, that'll be helpful to you. So don't focus on that, because that's like the answer right there. Okay. So you can still see my screen, I'm hoping. I'm going to minimize this a little bit. Whoops. Hold on. I missed my trackpad button. Here we go. Okay. So we have, now I can't go full screen on this, because I need to be able to look at stuff. All right. So, but I am going to make this bigger though. Okay. We're going to go for that. All right. Hopefully that's big enough right now. So I'm going to have an AWR report. Okay. And it's pretty straightforward. You can, I have actually on the ORPEB website under tools, you know, log in, you can be a free member, right? Free means free, it doesn't cost anything. Well, you're going to get some emails. Okay. So I guess that's your cost. But under the tools area, there's like a time-based analysis. It's something like, it's either called a time-based analysis template or something else, but it's there. Okay. Spreadsheets are great because then you don't make math mistakes unless you type over formulas. But if you just type in the yellow stuff here, you're good. Okay. And almost all the spreadsheets on my website are where you type in them is yellow. That's kind of my standard. So do you recognize CPU weight? It's just the same setup right here. So what I really love about this is that, like, I'm in charge. Okay. The AWR report is not in charge of me. I'm in charge of it. I'm the boss here. I know the numbers I need to get, and I'm going to go find them in that AWR report. So the first number I need right here is I need the foreground process CPU consumption. Okay. So what I do, just what you guys do. Well, I mean, you probably know your systems, but I'm like, okay, so 11.204, it's not rack, I'm Solaris. Interesting. 2018. I don't think I changed the date. So, okay, so we got a bunch of CPU cores right here. So that's cool. All right. And it's 30 minutes, which is nice right here. Okay. So I'm not looking at like some 4-hour snaps. Somebody sent me that. I was like, All right. So I scroll down. In terms of the efficiency percentages, I don't pay much attention to those except this one right here. Okay. This is important to me. This is my clue on an AWR report if I actually have a parsing issue going on. And I'll know that because parsing from a relative perspective can consume a tremendous amount of CPU. So, and just this is how you work with ratios, is that your experience has taught you that usually, right, this is the problem with ratios. Well, it's, in most cases, what I look for is if this thing is below like 98%. Okay. And what this means, remember, this is like a negative, double negative almost kind of a thing, right? What this tells me right here, it's about 0.6% of CPU is spent related to parsing, which is good. All right. But it's weird though, when you start dropping below like 98%, which means like 2% of the CPU was related to parsing, I start seeing parsing related weight events kind of bubble up to the top. Okay. And if they're not bubbled up to the top, and I'm at like 98, 99, or I'm getting close to that threshold, then that's my clue that, well, they're not bubbling up, but we're getting close. Now, that's a very general statement, and every system is, of course, different. But I actually use this. It's my way to tell if, I got parsing issues going on. With ASH, it's actually really easy to tell if you have parsing issues and exactly what SQL is related and all that kind of stuff. All right. So enough of that. So here's all the events right here. Okay. Now I know the reason I'm moving things around, the camera is literally like blocking this part of my screen right here. Okay. It's just the way I have it set up right now. All right. So what I'm going to do is I got over here, I'm going to fill out everything in yellow here. So CPU. So this is the DB CPU right here. That's the foreground process CPU. Now, one of the things that just bugs the crap out of me about these reports is when they have the thousands with the K, and then they don't do that on all of them, because I'm more likely to make a mistake. I have to like think harder because I have to remember, oh yeah, there's like 1, 2, 3, I got to move decimal points and all that. I can't just like eyeball this and understand like, whoa, there's the big, there's the time. Yeah, we can figure it out, but it's just more difficult to do that. So that's my gripe about that. All right, so DB CPU is about 8.3K, 18.3. So I'm going to put 18,300. I'm going to put that in there. Okay. Let's see. All right. Now let's look for the background. Now, and on your AWR reports, the more recent ones, Oracle is actually putting the background CPU time down here. And they used to not do that. As you can see, it's not here. And it really bothered me because I got, I'll just say this. Okay. background processes can consume CPU, usually not that much, but when there's a problem, when we care, they actually can consume a bunch of CPU. And we need to know about that. One, because why are they consuming more CPU than usual? But also, if you have a CPU bottleneck and the background processes are consuming CPU, that means your foreground processes are competing with the background processes for CPU. That doesn't sound like a good situation. So I want to know if the background processes are consuming a bunch of CPU. All right, enough said there. I keep looking at the clock because when I go on these little tangents here, I got to be careful. All right, so by the way, okay, here's DB CPU, and it's like, I was looking at this morning, just like, and I'm like, the numbers don't match. And I'm like, well, wait a second, this is rounding. So if you round it to like 18 point something, okay, that's going to be 18.3. So that does match what was up above. It doesn't always match because there's other sources for CPU. And I thought that's what the developers did on this report, but they didn't. So that's right. Way down here, here's our background CPU time right here. So that's like 160 seconds. So I'm going ahead and put 160 seconds right there. And it looks like the math is being done right. I love that. That's why I like the spreadsheets. When I do my classes, a lot of times I'm just doing this on a text file. And so I'll just do the math myself. It's always scary. Live math doesn't work out too good for me. Okay, let's go up here. All right. All right. So next we have DB file sequential reads. All right. Now this is where a lot of people get kind of hung up and until you just do it, a couple times. So the question is, okay, is this IO? Well, yeah, it says DB file. That's a pretty good clue right there. So the way that I kind of just check, if I'm not sure, I ask myself, okay, is the process waiting for a block from disk, or is it waiting for an acknowledgement that the write has completed? Right. If one of those is yeah, well, then it's going to be IO. Okay. Because sometimes it can get, until you're used to doing this, or like if you're not used to thinking like this, it's not as simple as it might sound. So like I understand that. All right. If you're feeling that way. All right. So this is like DB file sequential read. Oh, and it's a read. All right. Okay. You can figure that one out. And we're going to have, what do we have? 18,000. Okay. Now I can get more detail below than just, but I don't remember, we're not landing the man on the moon thing here. I just need some main numbers. Okay. Log file sync. Okay. Log file sync is the wait time related to a commit. So there's going to be some writing going on. Okay. You could also classify this under other. In fact, Oracle probably would. I think they what is this, concurrency? Is that what they classify that? I forget, or maybe configuration. I don't know what they do. Anyways, I typically put it under other because I know there's some IO going on with the log file sync. Okay, so that's where I typically put it. Hey, but if somebody gets all this aggro on me, like, hey man, I can't deal with that, Craig. I'm like, no problem. Then write it where you're comfortable, because it doesn't make any difference as long as we understand like what's going on. Okay, we're trying to do this to help ourselves. All right, so we got 13,900 right there, right? 13.9K. All right, that's a big chunk of time, okay, especially compared to these other ones right here. Okay, SQLnet message from DB link, and then, the TCP socket. Like, oh man, really? I hate those kind of wait events, because DB link, that means we're dealing with, there's another system out there that's going to complicate my analysis. Like, dang, okay. So it's not IO and it's not CPU. So that's other. So, but I am going to put that in there because that is significant time, especially those two together. Okay. So this is the TCP, socket. And that's good enough. I don't have to, oh, no, I'm not going to write the KGAS, which could be important to me. Understanding the wait event. By the way, that little kind of clue I gave you earlier about like, what does the wait event mean? Ask yourself, like, how is this wait event? How is that preventing the process from burning CPU? And then when you look at blogs or Oracle documentation or Oracle support, notes and stuff like that, ask yourself, okay, how is this preventing the process from burning CPU? It kind of helps clarify and helps us understand what's going on with the particular wait event, especially if it's one that you're not used to, which like it might be this kind of wait event. Okay. Oh, I forgot about the DB link one. Okay, let's put that. That's going to be here 67631. Right. Okay, so this is going to be my SQLnet. I'm just going to put from DB link. Yeah. Okay, and that's 7780. Okay. Okay. All right. All right. Now, okay. All right, we got 15 minutes. All right. So do I keep going? Do I just do? Yeah, that's a common question, right? Okay. Here's how I determine where to stop, because I don't want I don't want a bunch of numbers up there. Not only for me, more to look at, but I don't want other people to be fixated on something that is not important, that I may not know what it's about, right? And who cares if it's not important? And sometimes people feel that they have to ask a question, even though it's meaningless, what I'm saying the answer is. And so I don't want to give people the chance to ask a question about like, what, hey, so Craig, what's this buffer busy wait thing mean? I thought Oracle like didn't lock, read it or whatever, I'm like, oh dude, really? Like it's 711 seconds and we're dealing with like 18,000 here. Yeah, but what does it mean? I'm like, yeah. So I just I will not include that. Okay. Now, so how do I know where to stop? Okay. One way to do this works really good for me, is I say, if I completely eliminated that time through my amazing tuning prowess, right? I just, boom, zero, it's gone, doesn't even show up. Will that change the flow of the river? The current, right? The main current, the story, the epic, the meta story, whatever, the story. If I eliminate 711 seconds, is that going to be like, our analysis is going to go this way? No way, right? If I eliminate the 18,000, oh man, that's going to change the story big time. So that's how I do that. It's typically like an 80, 20, 90 kind of thing. Okay. Remember, we're looking for the big chunks of time, the big opportunities. Okay. So that's how I, kind of figure out where to stop. Okay. So that means we're done. I'm done with the AWR report right now. Okay. I typically do not go down any further on that. Even for like IO times and all that. I'll tell you, I will use, because it's going to come up right here, let's just talk about this big chunk of time. So I'm going to leave the AWR report up right now. Okay, we're going to talk about solutions here. Okay, so clearly our big chunks of time here is we got a bunch of wait time. Okay, and really in terms of what I want to focus on here and what's important is going to be the sequential the reads and the writes here. Okay, I'm not going to worry about the network related wait events unless I'm like, I know what that's all about. Maybe it's time to focus on that. Okay, because that is a significant amount of time, but that may be really difficult and you just don't want to go there. So you might just say, hey, this is application specific. That's the other team, whatever. And so maybe you just don't want to focus on that right now. I mean, that's valid. Okay. But one thing I will always do though, I was to say I never do, is I will not say, you know what, that's just inconvenient. We're going to leave that off. Even though it's significant time, no, I don't want to do that. I would rather say, listen, this is why I don't want to focus on this. Okay. And I hold other people to this, because some people in some teams say, hey, don't even mention that, Craig, because that's going to be a nightmare for us. But I'm like, but it's the best solution possible. Like, yeah, but it's such a hassle, man. I feel like saying like, grow up, man, just, yeah. So it forces a discussion, and I think that's really, really important. Okay. So, so let's just kind of go down here now. Since these are kind of equal, it's pretty bizarre. And it's not always like this. All right. So from how do I reduce CPU consumption from an Oracle perspective? Unless there's some instance parameter, well, I don't really know what that is just because of CPU. Okay. Sometimes if it's other, like cache buffer change, well, that will definitely influence CPU consumption. So really, I don't have anything, nothing right now. How about from an OS perspective? Well, if there's a CPU bottleneck and I'm hitting the limit, there's no CPU available, so I can't even consume more, then that's important. So my next step is ask, figure out, is there a CPU bottleneck? Okay. All right. How about it from a SQL application perspective? Well, you look for the top CPU consuming SQL statement. And like, that's one of the key, that's going to be some of your key SQL statements. And I love this because it tells me why I want to focus on a SQL statement. It doesn't tell me how to tune it. It doesn't tell me what's wrong with the statement, or even if there is something wrong with the statement, but it tells me why I am focusing and talking about a specific SQL statement. Now, I don't tune SQL anymore. I just don't, but I can tell you what SQL statements to focus on. And sometimes you know which ones, and sometimes you don't. It's just this big ocean of activity, and you need to figure out which SQL to focus on. This will point to the SQL that's really important. Okay, so I'm going to look for the top CPU SQL, and you know how it's in the AWR report. Just click the button and go, and like boom, there they are. Okay, all right. Since we will run out of time, I'm gonna get going. Okay, so how about an Oracle perspective? How can I reduce DB file sequential reads? Now remember, I'm not recommending these. These are just possible solutions to consider that you just write on the board and then you have a discussion. All right, so one of the reasons, right, where we have DB file sequential reads is because the block is requested that was not in Oracle's buffer cache. So what can we do so the block is actually already in the cache? Well, from an Oracle perspective, one thing we could do is we could have a bigger cache. Now, some of you will say, well, Craig, we just can't have bigger. Well, then we'll just but that's a discussion that we just had though. So you can just mark that off and say, no, we don't have memory for that. Okay, all right, fine. So then, but we have other solutions, thankfully, right? So for this one, I'll just say consider, I'll put consider. Increase caching. Now, there's multiple ways that we can mess with Oracle's caches, right? There's different types of caches. There's a lot we can do. On an OS perspective, we're talking about IO reads. So is there an IO bottleneck, right? Is the response time really slow? Well, we can get clues here. I love this. This is one of the best numbers to tell if I have an IO read situation, okay? Here's the average wait time right there, 30 milliseconds for one IO, like one block. Come on, man. That's not slow. That's busted. So there's something really, really not right there. Is it broken? Is it busted? No, it's probably just Oracle's throwing so much IO, it just can't take anymore. But that's it. We need to, from an OS perspective, can we get more IO read power capacity? Now, is that the real solution? Don't know, but it is a solution though. Okay, so that is to increase IO read capacity. Okay, SQL, pretty obvious, right? You find the top read SQL, get the top IO read SQL, and you can find that. You click the button, boom, and you'll go right to it. Okay, log file sync. Log file sync is a very interesting one, and we just have a few minutes. Okay, remember, log file sync, that's the wait time related to a commit. Now, from an Oracle perspective, think about instance parameters and really cool things you can do. There's this, I'll say, this facility called commit writes. Now, before you write this off with what I'm going to say, okay, there are actual really good use cases for this. Okay, so there's this thing called the commit write facility, which basically means as soon as a commit is issued, Oracle says, oh yeah, it's done. But the redo may not be on an online redo log just yet. So yeah, you can lose data. But there are some really good use cases for that. And they all center around, well, if we do have a failure, we're just going to restart the process anyway. So like, what's the big deal, right? That kind of thing. So, or it's a batch process and we'll just restart it if something fails anyway. So it's like, who cares? Enabling, and there's different ways you can enable that, instance-wide, session-wide statement, you can do that. It can just completely eliminate log file sync. It's super powerful. So whenever I see log file sync in Oracle perspective, I'll just say consider commit right. And I have a number of blogs about this, where I've done some research, studied it, and and all that kind of stuff. So if you're interested in that, check it out. If you haven't heard of that, it's like, you need to know this as a DBA. Okay. Don't tell anybody you're considering about until you're comfortable with it, because they're gonna write you off. All right. Log file sync. Check and see if there's an IO write bottleneck. There's an IO read bottleneck, so there could be some write issues as well too. You can actually look at the wait time for log file sync. Whoa, okay. Usually that's my response right there. Usually I find if it's greater than 5 milliseconds, then people are not happy with performance. Okay, but it depends on your IO subsystem though. 1 millisecond might be too long for some of you. Okay, but that's crazy. All right, so there we have an issue here. So it's IO write bottleneck. I'll just say IO write, more capacity. You want to do that same kind of thing with the read right there. Okay, SQL. Okay, every time I get commit, I mean, I'm serious about this. If there's a log file sync, it's rapid commit. So the application is just going like commit, commit, commit. It's almost like a looping. In fact, sometimes it is a loop, because the developer is not really sure when the commit is going to take place. So just to make sure it takes place, because they don't want to lose data and be responsible, you have like a DML statement, and then right after that, there's a commit. So you just have DML commit, DML commit, DML commit. Guaranteed log file sync if you have multiple sessions doing this, okay? At some point, it's just going to happen. So you need to figure out where that is in the application. And I would say most DBAs kind of have a hunch where those rapid commits are taking place. So if you can just even do DML commit instead of DML commit, just have like 2 of them, just write a little subloop or do something like that. If you can do that, you can pretty much eliminate log file sync. And I've done a bunch of research on that too. And it's amazing. If you look at the chart, it's like, this is like one commit, or one statement, DML commit. This would be like DML commit. I mean, it's a huge drop in terms of the throughput that you can get through the system. It's mind-boggling. So for the SQL, for the high, when I put in my notes here, I want to. There might be something specific I was thinking of. Oh, just you need to look at rapid commits. Yeah. This is weird. Okay, just about done here. Okay, I think that's about it. All right, so you see we have a number of solutions right here, and we have some other things we need to check out, like, is there a bottleneck? Talk to the IO guys. By the way, never say IO bottleneck. People, they don't say a bottleneck to anybody except your fellow DBAs. Okay, all right, let's finish up here. Let's see, make sure there's no other questions right now. Okay, good. I'll stay on for a minute if you guys have any questions. You can always email me too, by the way. Okay. All right. So that was just an example of doing that. This is kind of what I came up with right here. That's in the notes as well. All right. All right. Now, hey, this is, yeah. Okay. I had to read that. See my eyes doing that. It just works. It just works. I don't know how else to say that. Okay. Now, this is just the beginning, really. But you should, get good at this, right? Getting it set up, coming up with solutions. And what you're going to find is that there's a bunch of other things you're actually going to need to know about. Okay. And this is like a list of these things. I didn't want to start with this because you're like, wow, this is really overwhelming. But there are a bunch of other things that you're going to have to deal with when you do this. But if you set it up right, then you're going to be going the right direction, right? And that's what we really want to do here. That's really what we want to do. All right. If you want to go deeper, if you're interested in machine learning, I got like this free e-course. That's the URL. Okay, just ML-e-course. It's 18 sessions. You get an email, you go through it. Super easy. Check that out. Other related resources. I do AWR classes. The next one's going to be in the fall, though. That's what's probably going to be, though. All right. On my blog or my website, or it's not my website or my blog now, but Craig's blog, search for AWR OTBA is another keyword here, or just Oracle time. I've done like so many experiments related to Oracle time. Okay. Monica talked about the presentations and all that kind of stuff. Thank you all for taking your lunchtime here for most of you to actually to listen to this. Right. If you have any questions, go ahead and chat those in, or you can always email me and I'll respond for sure as well. So yeah, thanks for being here.
Thank you so much, Craig. And thank you again to everyone who joined us today. Again, you can grab this webinar and the slide deck at aurapub.com. Go ahead and sign up as a free member. Take a look around and you'll get a notice when it's up. Thank you guys so much. And thank you, NYOUG, for continuing to do these webinars with us. We hope to see you all again soon. Take care.
Awesome. Thank you guys for being here. Yep, no questions. All right. Until next time.